Okay, so let's continue with an example here with the mesh analysis example. So I wrote my first equation corresponding to this loop right here. Now I need to write my equation corresponding to this loop right here. So again, I have to select a point. Where is it that I want it? So I'm going to say this point is my starting and ending point. So I go this way. So I have my voltage drop across this resistor is equivalent to the resistor times the current, in this case I2. So 6 times I2 is the voltage drop across this resistor, so that is 6 times I2. Then I continue. I have plus 18. Here I just write the number because it's already a voltage, so plus 18. Then I continue and I go. Now I again have this resistor that it is in common to both loops. So this is usually the case is going to have in mesh analysis. We are going to have a resistor that makes the link between the two loops, between the two currents, and that is exactly what we want. We don't want them to be independently because then we have no relationship between the two, then we cannot solve it. So right here we go. Now we are entering this way. For this case, we say that going up is positive, going down is negative. So I have 4 times I2 minus I1. It's 2 minus 1 because I2, we are assuming is going up is positive, going down is negative. So if you see, it's exactly the same but opposite sign as equation number 1. In equation number 1, we have I1 minus I2. Why? Because we always assume the direction of the loop current is the positive, and anything against it, it is negative. Anything opposing it, it's negative, okay? In this case, we are doing loop 2, so the current direction goes up to be positive, the coming down is negative. That's how we get I2 minus I1 plus 18. So now we have two equations, two unknowns, I1 and I2. At this point, we can simplify it, we can multiply out, and we get these values. So this now we have equation 1 and equation 2. Equation 1, we have 6I1 minus 4I2 equals to 16, minus 4I1 plus 10I2 equals to negative 18. At this point, you are welcome to use any method. You know how to solve a system of equations. We're going to learn a matrix method called Cramer's method, that it is widely used when we have a 2 by 2, 2 equations by 2 formulas. I mean 2 equations and 2 unknowns, but it doesn't have to be used, okay? In this, I'm showing you the use by manipulating the coefficients of the unknowns and adding the 2 equations, I can successfully solve for the current. So here I realize that I decide first, I have to say which one, I2 or I1, I want to get rid of it. Once I decide that, then I have to find a multiple relation, a multiplier relation, that by doing that I can cancel it out. So here, if I multiply this by 2, I get 12. If I multiply this by 3, I get 12. They are opposite sign already, so if I add them up, I1 will disappear. And that's exactly what I did. I multiply this by 2, so I get 12, I get 8, and I get 32. I multiply this by 3, so I get negative 12 plus 30 and negative 18. No. 3 times negative 18, I get negative 54. Then I add them. These two goes to 0, and I have 30 minus 8, I get 22. 32 minus 54, I get negative 22. So I2 is actually a negative 1 ampere. Okay, very important, keep the sign, okay? Keep the sign, don't worry about having a negative current. We are going to talk about that in a little bit. Then I have my I1, my I2. I'm going to go back to either of these 2 equations, and I'm going to plug in back the value of I2. So I'll do it in equation number 1. So 6 times I1 minus 4 times minus 1 equals 16. So I solve for I1 and I get 2 amps. Okay. So now let's talk about this negative sign here. So I2 is positive, is fine. This is what we want. We want positive values. So this tells us that the I2 is actually going like this. It's going from here to that. So it's going clockwise. Okay, so that tells us yes, the proposed direction was correct. Now with I2, we say that it was going clockwise. It was going clockwise. And what do we get? We get a negative value. So that means that the proposed direction was wrong. That actually I2, it goes counterclockwise. I2 comes counterclockwise, and that makes sense because look the polarity of the source. We are saying that the current goes into the source, and usually current goes away from the source. So the proposed clockwise direction was wrong because we were going to the source, and we usually go away from the source. But we didn't care. We say they suggest us to go clockwise, so we do it clockwise, and then once we solve it, we realize that it was a negative as an answer, so we just reverse the polarity of it, and that is going to give us the right polarity or the right direction for current. That's why I say don't worry so much about saying, okay, this is positive, so you should go this way, this is supposed to be that way, but which one dominates? Is it 16 or is it 18? We don't know, so we just follow the steps, and then the math is going to take care of itself. Now we want to find the current, the resultant current of I4, current at 4 ohm resistor. So here we are going to say I1 minus I2. Okay, I can use this formula. So I1 minus I2, it is the one I use. So it's 2 minus 1. So I get 3 amps. Okay. So basically what it's trying to say is that if I use this other form right here, 2 minus I1, I will get 3 amps, but negative. So if we just analyze the node here, we just say that, okay, this one is clockwise, this is counterclockwise. So I2 should be the sum of the two, okay? The sum of the two, and it should go down, okay? So the clockwise direction for I2 is the correct one. That's why we use this formula, so we get a positive answer. So that's how we did that. And that concludes our mesh analysis example. So let's stop right here.